Now, for this chapter, the application layer, chapter 12, CCENT, we could spend days and days and days talking about applications. All right, but our objective for this particular chapter is to only introduce you to some applications at a very, very high level. So we don't spend a whole lot of time in this class talking about the application layer because really it's not that important when it comes to infrastructure. Routing and switching are the key components to our infrastructure design, management, support, and so on. But there are some applications that we use on a regular basis that we need to talk about in this chapter to have a pretty good understanding. The application layer is layer 7, but in a lot of cases, anything above layer 4 generally gets classified under that layer. We see the session layer, the presentation layer, and then the application layer. The session layer is to the application like TCP is to hosts. It allows us to establish communication channels between applications. And as you can see there, mostly theoretical is how it's defined. That's because we don't typically deal with the presentation or the session layer that much. At layer 6, we have the presentation layer. It is literally what it sounds like. This is how data is presented to the application. In other words, the format of the data. Is the data formatted as a JPEG? Is it a GIF? Is it a bitmap? Is it HTML? Is it XML? Is it SHTML? Different types of formatting. The application layer itself is all of our network processes or applications that are running on our hosts. Things like HTTP, DHCP, SSH, Telnet, etc. These are some of the common applications that you need to be familiar with when it comes to Cisco certification. You will see references to these applications probably on the first exam, maybe on the second exam. DNS, an application that allows us to resolve internet names to IP addresses. Or they don't have to be internet names, they could be servers, hosts, computers, routers, whatever. Domain Name Service Protocol, DNS. It operates at both the TCP and UDP stack, and it uses port number 53. TCP primarily for things like server-to-server communications, like zone transfers, replication, etc. UDP for client-based transactions, like DNS queries. Telnet, of course, you guys know what Telnet is. It is a terminal emulation protocol used to remotely access and manage devices. TCP port 23. Bootstrap. Now, you may not have heard of the Bootstrap protocol specifically, but the Bootstrap protocol is a sub-protocol to DHCP. If you were to go into Wireshark and do a Wireshark capture of a DHCP transaction, you would actually see port 67 and 68 being used, because that's what we use for DHCP. I just realized if I flew up too high, I would have knocked that sprinkler head right off. That would have been bad. All right. BootP, the Bootstrap protocol. Let me see, we have a question here online. Domain name system. Yeah, a domain name system is how it's technically described, but it is a service that runs at the application layer. All right. So yeah, I appreciate you pointing that out. Technically, the protocol is called domain name system because it is a system of servers and communication architectures, but DNS provides us the process of resolving internet names to IP addresses, okay? So I think there that it's kind of it probably should reword that, right? Because the rest of these describe the actual name of the protocol, whereas that is really describing what the service is, right? So the Bootstrap protocol, or BootP, was actually the precursor to DHCP, but it's still used by DHCP to provide auto configuration of our clients that are attaching to the network. It uses UDP port 67 and UDP port 68. Those are the two sub-protocols, BootPC and BootPS. The C stands for client, the S stands for server. We're actually going to spend a little bit of time in this chapter talking about the DHCP process. It is such a widely used protocol, and it's inherently critical for clients communicating on the network, that we do spend a little bit more time talking about the DHCP process. FTP, the file transfer protocol, used for interactive file transfers between our systems. Now, initially, we used two different port numbers for FTP, port 20 and 21. These are used for establishing our session, and then we use other ports for actually transferring data. Typically, it's going to be higher order port numbers that we use to transfer the data. Then we have the trivial file transfer protocol. We know what that is. That is the protocol that allows us to copy files to and from our system. The only difference in this case is this is a connectionless protocol. When I say connectionless, what does that mean? It uses UDP. We don't have official connection establishment before we send or receive the data. So we mentioned these particular applications, but we know there are thousands of applications that exist. These are just some of the common ones that we'll see. So let's talk about DHCP, the Dynamic Host Configuration Protocol. I think everybody here has a pretty good understanding of what DHCP does in general. DHCP allows us to establish properties of a host connecting to our network. It allows us to assign things like IP address, subnet mask, gateway, DNS information, WINS information, even the domain name information, like the domain that the client might belong to. In addition, we can assign other things like TFTP options if we have phones that are booting up on the network, or other types of options. There are a lot of options that you can specify within DHCP. All right? Why do we talk about DHCP specifically in this class, though? Well, the problem with DHCP is how it functions, at least in IPv4. How does DHCP function in IPv4? It is broadcast-based. Why would that be of a particular concern to us in our network, especially as a network engineer?
To give us an idea how it does it assign the IP address to the host.
True, we need to know how it assigns addresses, but when you hear about a protocol being broadcast-based, that should raise a red flag, shouldn't it? Because that means it has limited scope, doesn't it? What types of devices do not allow us to forward broadcasts? Routers. And because DHCP is broadcast-based, it doesn't go through routers. Not natively, anyway. That's a bit of a problem, because that means one of two things. Either I have to statically assign my addresses on the host behind the routers, or I have to have a separate DHCP process on every single subnet. We know that neither of those things exist in the real world. In the real world, we might only have one DHCP server or two DHCP servers. In the real world, we don't statically assign addresses to everybody. Right? Scott is correct. Scott says IP helper. Absolutely. In Cisco, there is a function in a router that we can configure called IP helper. We're going to talk about how that works here in a minute. Okay? What is the purpose of DHCP? As I mentioned, it allows us to assign specific properties to our clients. We do have DHCP for IPv6 as well. It's not necessary all the time, but it does exist. Usually with IPv6, if we're doing things like auto configuration, where we're using the EUI64 process, DHCP would be used to assign other properties, because the EUI64 process doesn't include things like assigning the domain name, or assigning a Win server, or the DNS information, and so on. So we would use IPv6 DHCP to add those additional features. It's what we call stateful auto configuration as opposed to stateless. Stateful auto configuration means that we're using DHCP to supplement our EUI64 process. Within DHCP, we have 3 methods for assigning addresses. We can do dynamic allocation, we can do automatic allocation, or we can do manual allocation. Dynamic allocation is the one that most people are familiar with, where a client goes out, sends out a DHCP discover, gets a DHCP offer, sends out a DHCP request, and gets an acknowledgement. That acknowledgement includes an address assignment, mask assignment, gateway assignment, and then on top of that, it also includes a lease time, meaning that that client can use that address for a specific period of time. Once that time is expired, the client needs to renew its lease by sending out another discover and going through the process again of renewing its lease. Automatic allocation is exactly the same as dynamic, but the only difference with automatic is there's no lease time, meaning that once the address is assigned, the client keeps that address, well, forever. Now, that doesn't mean that the address then becomes a static configuration on the client, but if the client loses power and you boot the client back up, when it does its discover again, it's going to get assigned the same address that it had before. Yes, sir?
So in the manual allocation, if the host of the device loses power, it's going to do the whole process again, right?
Dynamic allocation. I started from the bottom up.
Oh, sorry, the dynamic allocation.
Yes, dynamic allocation. Actually, that's not completely true. As long as the lease period hasn't expired, that address is reserved for that client. Even if the client reboots, when it goes out and does its discover again, as long as the lease period is active, it'll get the same address again. If the lease period has expired, in the time that you shut the computer down and the time that it did its another discover, if the lease period has expired, then it may or may not get the same address, but it has to renew its address. Okay? Manual allocation still uses the DHCP process, but in manual allocation, what you're doing is you're going into your DHCP server scope and you're saying MAC address X always gets IP address Y. We see customers doing this a lot now with their servers. Traditionally, what would we do with our servers? We'd go into our servers and we would statically assign our addresses, right? Like on the server itself, configure the IP, configure the mask, configure the gateway. The problem is when you need to change that address, if that ever became a thing that you had to do, you would have to go physically touch that server or log into that server to do that. By using DHCP, all you have to do is change the scope. All you have to do is go into your DHCP server and change the address allocation in your scope. Additionally, you have a repository or a database of all the addresses of your devices in one location. All right. The downside to this approach, doing manual allocation, if the DHCP server is not available when the device boots up, then the device can't connect to the network.
What if like the DHCP server goes down? So the device loses it.
If the DHCP server goes down while the devices are active, it will not affect those devices.
Okay. Like it would only affect the
That's right. That's right. If the lease time runs out and the DHCP service is not available, then we won't be able to renew our lease. Okay? All right. So the discovery or the DHCP process is broken up into 4 steps. Step number 1, DHCP discover. The client sends out a broadcast. The source address of this discover is 0.0.0.0. The destination address of the discover is all ones, 255, 255, 255. Oh, I'm not going to write it all out. Okay, so it's a broadcast. It's an all-host broadcast. The source MAC address of the discover is the client's MAC address. The destination MAC address is all Fs. So it is literally a broadcast at layer 2 and at layer 3. Any DHCP server that sees that discover, any DHCP server is going to send an offer. The offer is also a broadcast. I can't send the offer to a host because the host doesn't have an address. So the offer is also broadcast-based. What does the offer include? The offer says, hey, this is what I have to offer you. This is what I have to offer you. This is the IP address, this is the lease time, this is the mask, this is the gateway. The client gets that offer, it sends in a request. The request is a message going to the server saying, I like what you have to offer, specifically, and I want to officially register with that address. Now, inside that DHCP request, in the payload, we identify the actual server that we're trying to register with. Not in the IP header, not in the data link layer header. That's still broadcast-based, but in the DHCP payload, we see this server's IP address listed. So that server verifies the lease, sends an acknowledgement to the client saying, okay, you can now use this address. Check back with me in X amount of time, whenever your lease time expires, and we'll get you all set up to renew the lease or to get a different lease. We call this the DORA process, D-O-R-A. Oops, missed the A there. D-O-R-A. Discover, Offer, Request, Acknowledgement. Again, almost 100% of this communication process is broadcast-based, which means that we have a big problem when it comes to passing this traffic through routers. In order to allow DHCP traffic to flow through a router, we have to use something called IP helper. All right? At half the lease time, when it says, I want to keep this IP, does it go through the same steps? I'm not quite sure, actually. I know that there is some sort of communication from the client to the server about halfway through the lease time, but I don't know if it's the exact same 4 steps. I've never actually looked that up. Okay? I would imagine it's a subset of those steps, but I can't say for sure. All right? If anybody online knows that, you can let us know. Yep, that's the best answer I could have received. I'll Wireshark it and see. Absolutely, that's what we like to do. We know how to interpret Wireshark data now. That's how you can identify what's happening on your network. Capture it in Wireshark and take a look. Okay? Now, if your lease time is 8 hours, you might have to wait a while, but you can adjust your lease time in your scope to 30 minutes or 5 minutes or whatever to see the transactions as they go through. So what does this IP helper command do? All right? Now, it's not to say there aren't other vendors that can do this. I'm speaking specifically from Cisco's standpoint. This is how we would deal with DHCP in a Cisco environment. We use IP helper. And what IP helper does, what IP helper does is it makes this router a relay agent. DHCP relay agent. The router doesn't forward the broadcasts Instead, what it does is it converts those broadcasts to a unicast address and forwards those on to the server. It's not quite a conversion. It's actually a relayed request, so the server knows this information is being relayed from the router. The client sends out a discover. The router intercepts that discover, and because it has this configuration, it sends a proxied request to the DHCP server. The DHCP server replies with an offer. The router then sends that offer to the client as a server would. So the client is completely unaware that there's a proxy agent acting on behalf of the client. The client sends its request. That request gets relayed to the server. The server then sends its acknowledgement, and we're all said and done. So technically speaking, as long as this router can route to this IP address, that DHCP server could be anywhere in the world. Here's an interesting thought, though. How does the server know what address to assign to the client? If the server's not in the same network, and you can imagine we might have other interfaces that also have helper, so we're passing requests from this subnet, and this subnet, how does the server know which address to assign from which scope? Because of the relayed interface. The IP address of that interface is identified in the relay. So the server looks at the address that the relay came from, and it says, oh, you're in network X. I'm going to go ahead and assign an address from network X because that proxy request came from network X.
So that information would be included
in the
data that's
being relayed. Yeah, that information gets included in the proxy request. And the server might have 5, 6, 10, 100 different scopes on it. So essentially on the server, all you'd have to do is define a scope for each subnet that the server is providing the service for. Very, very simple concept. This works, by the way, on interfaces. It works on sub-interfaces. It works on SVIs if you're running routing on a VLAN interface. And it's very simple, IP helper. What if I have more than one DHCP server? If I have more than one DHCP server, I simply list them in order. Now the router does not try one server, then the next, and the next. What the router does is it sends a request to all the servers. And whichever server responds first, that's the information that's going to be relayed back to the client. Any questions about the helper command? You will not configure a Cisco network today without this option built in. We see helper all the time. Now, you can also set up a router as its own DHCP server. And actually, the routers do very well. They can handle thousands of DHCP requests. Here's a sample configuration of how I would configure a router as a DHCP server. And you could actually take this config, you could build a little packet tracer lab, put this in, and see this functioning in your packet tracer environment. All right? Here's the first step, setting up the pool. Now they did something here that I didn't like. They put the name of the pool in lowercase. I would have done that in uppercase. And what did they specify in the pool? They specified the network that the addresses are coming from. They specified the default gateway for that subnet, DNS information, all the things that you would expect to see in a scope. And actually, the scope options in a router, not bad. There are actually quite a few different scope options that you can set up. You might not get all of the features that a server might give, but for the most part, DHCP on a router works very, very well. It's not just the basic options you can assign. You can assign a lot of the enhanced features as well. All right? Now, the other thing that is slightly unique about DHCP on a router is how we do the exclusions. I don't quite understand why they did it this way, why they didn't put the exclusions under the DHCP pool. You put the exclusions in global configuration mode. And that exclusion is just a range. So we're excluding 1 through 10 for this particular pool. Now, can I do multiple scopes in a router? Absolutely. If I have a router, I have scope 1, scope 2, scope 3. Let's say this scope is the 10 subnet, that scope is the 11 subnet, that scope is the 12 subnet. How does the router know which scope to pull an address from? Because it has a 10 interface, it has an 11 interface, it has a 12 interface. If a client here sends a request, if that comes in on the 10 interface, we're going to pull an address from the 10 scope. If it comes in on the 11 interface, and so on. If it's a router down here with another network over here, how do we get this DHCP request, let's call that 13, is the 13 subnet. How do I make sure that that router can act, this router here can act as my DHCP server for this subnet? I put IP helper on this router to point to that router. Make sense? Why do you exclude certain addresses? Are those the ones you have statically assigned? Yes, absolutely. You exclude addresses because you don't want them to be part of the scope. You might have network devices that use static IPs. You might have servers that use static IPs, and so on. And I agree. We would not put just one DNS server. We'd like to have some redundancy built in. You can do manual allocation with a router. You can do dynamic allocation. You can do automatic allocation. So a lot of the features that we talked about with regard to DHCP are available on a router. All right? So I told you that wasn't going to be too difficult, that particular chapter. Pretty basic chapter. All right?
With, going back to the